Hi, everybody. Today I'm going to go over some of Regents questions for sequences and series. So today, actually, I'm just going to focus on sequences. So let's start here. Again, I gave you this before. This is the formulas that will be on the formula sheet for the Regents. These are the explicit formulas. The recursive formulas are not on the sheet, and you need to know that. So you need to memorize the arithmetic recursive formula. It has two equations. A sub 1 equals whatever the first value is, and then a sub n equals a sub n minus 1 plus d, where d is the common difference, and d can be positive or negative. The geometric recursive formula is a sub 1, you give the first value, a sub n equals a sub n minus 1 times r, where r is the common ratio, and can be positive or negative. When you look at the sequence, if you see that the values are going from positive, negative, or negative, positive, either way, you'll know that r will be a negative value. Okay, so let's take a look at this question. I sent this to you. It's on Google Classroom. So if you didn't print it out yet, pause and print it out. If you don't have a printer, just read the question along with me and do the work on a piece of loose leaf. All right. So, after Roger's surgery, his doctor administered pain medication in the following amounts in milligrams over 4 days. So these ends, these are your sub ends. So this would be a sub 1, 2,000. That's the dosage. A sub 2 is 1,680, and so on. How can this sequence best be modeled recursively? Okay, so now right away you can see they want us to use the recursive formula. So you can cross out the explicit ones. Now I found the common ratio by using my calculator. Notice you take this number divided by that. So you're taking a sub 2 and divided by a sub 1, a sub 3 and divided by a sub 2. And you get a common ratio. Here it's a little off because they rounded those numbers. But I can see from the choices that 0.84 must be the common ratio. So I'm comfortable with that. And so right here is using the formula directly from the front page, which you have memorized. Just substitute M for A. All right. And you get choice 3. All right. A recursive formula for the sequence. Again, for some reason they like to do recursive formula, so make sure you memorize it. If they're asking for a recursive formula, you need 2 equations. So again, I know I can eliminate the explicit ones, okay, with just 1 equation. So 2 and 4 I can eliminate. Again, take 9 and divide it by 18, you get a half. 4.5 divided by 9, you get a half. Therefore, the common ratio is 1/2. Don't forget, the recursive formula needs 2 equations. So g sub 1 equals 18, and g sub n equals 1/2 times g sub n minus 1. You can see this is the same as choice 1. Okay. They're giving me a sequence, and now they're giving it to me in their recursive format. Now I know it's going to be geometric because I see the 3 as being times by a times n minus 1. So I know it's geometric. All right, the common ratio is 3. A sub 1 is 6. So again, this I got right from the formula sheet. Just plug in the numbers. All right. Now this is a little bit off because it doesn't match anything. So what do? Well, you can convert number 6 to 2 times 3, right? And then you use the powers that you know that 2 times 3, okay, so I'm changing 6 to 2 times 3. 3 can be written as 3 to the first, all right? Notice how you can combine these two at the same basis by adding the exponents, and that's where you get your answer, that it equals 2 times 3 to the n. All right, so Hence, when I get down here, I can come up here and realize that it's the same as choice 3. So they're testing not only your sequence knowledge, but your rules for exponential rules as well. All right, let's go to this one. This is they give me the sequence. They don't tell me which kind it is, but if I again use my calculator, I can see that it's a arithmetic with a common difference of 0.75. So again, I'm using my calculator. You do this number minus this number. So negative 7.25 minus negative 8 is 0.75. Do that again and again, and you'll see you're constantly getting a common difference of 0.75. This is a positive 0.75. The numbers are going up in value. Okay. I also know the first term is negative 8. So again, using the formula from the formula sheet, I get this. And you have to simplify, okay, to get this value. But you can check this very nicely. You can put this in your calculator as a y equals, see? And then you go to your table, start at 1, and notice that these numbers match what's above. So I know that this answer, my final answer, is correct. All right, so that would match number 3. All right, they asked us to write a recursive formula for this graph. Notice it has a curved shape, so it's probably geometric, right? My first term, a sub 1 is 4, a sub 2 is 12, a sub 3 is 36, and a sub 4 is 108. So I look at the change in my y values and I see there's a common ratio of 3, right? 12 divided by 4 is 3, 36 divided by 12 is 3, and so on. So for the recursive formula, again, a sub 1 is 4, my common ratio, and then 8 times a sub n. All right. This is the last one for today. All right, this is a little tricky. 4, 9, 19. I don't see a common difference and I don't see a common ratio. So this one wouldn't fall exactly into either arithmetic or geometric. However, I noticed that each value is 1 less than 5 times 10, 5, 10, 20, 40. So I start with the common ratio of 2. So when I write this down here as my possible recursive formula, it doesn't work. So what I'm thinking, well, I know when I plug in here n equals 2, I get 8. So I have to add 1. So I try this formula. Test it out. All right, so I see that a sub 4 is 39, a sub 3 is 19. I plug that in and yay, I get works. So my final answer is this. Again, it doesn't follow one of the exact rules, but with a little thought, you can figure it out. All right, so see you again later. Bye.